Okay, as I promised, I'm going to discuss problems that are similar to what I've given in your exercise. Um, let's start with number one. We will apply here the chain rule, okay, just as I've discussed in our first video. How do you apply the chain rule in finding the derivative of these functions? Now, obviously, the functions here are functions which are results of composing two other functions. Okay, like this one here. This serves as the exponent. I'm sorry for that one. But how do you find the derivative of this? First, to facilitate your computation, it would be easier if you identify your u, okay? In this case, your u should be 3x squared minus x. The reason for choosing that as our u is because this whole function here is the result of composing two functions, and these are f of x equals x cubed, and the other one is g of x equals 3x squared minus x. So if you compose f of g of x, the result is this given function. But anyway, obviously the function here serves as the argument of the bigger function or of your f, okay? So that's why we choose that as our u. So what is the derivative of this? First, let's express the function in terms of u. So f can be written as f of x equals, instead of 3x squared minus x, it can be written out as 2u cubed. Okay, and then this is a familiar form. The derivative of this is obtained by using the power rule, if you remember, which is 3u to the 3 minus 1, which is 2. But according to the chain rule, you have to find for the derivative of your u, okay, which is equal to 3 times, you can put back now the u, so you have 3x squared minus x times the derivative of your u, which is, your u is 3x squared minus x. So continuing here, we have 3 times, sorry, we forgot the square here. So 3x squared minus x times the derivative of this is 6x minus 1, right? Okay, then you can simplify by, there is a square here. You can simplify by multiplying this 3 with 6x minus 1. Don't commit a mistake of multiplying that with this, because there's an exponent outside. Unless this is simplified first, you cannot multiply this 3. So you can only multiply 3 with 6x minus 1, which is 18x minus 3, then times 3x squared minus x squared. Now, you don't need to expand this. What's important is we obtain the derivative of your f. It will take time to expand this, so you can leave your answer in this form. Okay, let's proceed to number 2. Again, I just would like to reiterate here that the expression sine squared theta is actually sine theta quantity squared, which is very similar to that one, right? Okay, in other words, the obvious choice of your u is sine theta, so that your h of theta is equal to u squared. So then, how do you find the derivative of h? It's equal to, following the power rule, 2u to the 2 minus 1, which is 1, after that, you have to find for the derivative of your u. Okay. Let's put back the u. Your u again is sine theta. Then you have to find for the derivative of your sine theta. Okay, simplifying further, we have 2 sine theta. What is the derivative of sine theta? Okay, and you can check in your list of differentiation formulas. Sine derivative of sine theta is actually cosine theta, right? So we have the derivative of sine squared theta. Next, number 3. It is important to be able to rewrite this into simpler form, wherein you can easily compute for the derivative. What I mean is, since we don't have the formula for a function that is in radical form, we can write this one in exponential form. So it can be written as x squared minus 1 to the 1/2, which is again of similar form with number 1 and number 2. So that means that we have to assign for our u x squared minus 1, okay, and then after that express your function in terms of u. So you can write that as u raised to 1/2, and then compute for the derivative. So this will become, following the power rule again, you have 1/2, the exponent, no, times u raised to 1/2 minus 1 is negative 1/2 times, according to the chain rule, the derivative of your u. Okay. And let's put back now the u expression for u. You have x squared minus 1 raised to negative 1/2 times the derivative of your u. Now what is your u? Your u is x squared minus 1. Okay? So, what is this? You have 1/2. By the way, you can write this as 1 over square root of x squared minus 1, right? Okay? Times the derivative of x squared minus 1, which is 2x. Now, you can see a common factor here, right? Which we can cancel between numerator and denominator. That means that this can further be simplified as x over square root of x squared minus 1, which is our derivative for g of x. Okay, let's proceed to our next example. This time we have the derivative of tangent x squared, but first we choose for our u. What is our u? The u here is the argument, of course, of tangent, which is x squared. Okay, so that the function can be written as y equals tangent u, right? And then to find for the derivative of this function, you have to find the derivative of both sides. With respect to x, the derivative of y is of course dy dx, and the derivative of this is, check your formula, that's actually equal to secant squared u, and according to the chain rule, don't forget the derivative of your u. Okay, then continuing here, we have dy dx equals, okay, let's put back the expression for u, which is x squared, okay, then times the derivative of our u. What is the derivative of our u? Dx of your u, which is x squared, so that's equal to secant squared x squared. What is the derivative of this? That's 2x. Or you can choose to write your answer as 2x second squared. I'm sorry. 2x second squared x squared for the derivative of tangent x squared. Okay. And last, what about the derivative of h of x equals 1 over 5 minus 2x cubed? I think it is important to write this in the form where we can easily compute for the derivative. So I would suggest to write this as 5 minus 2x to the negative 3, and assign for your u. So your u is 5 minus 2x, and then the function can be written as u to the negative 3. So using the formula now, this is negative 3 u to the negative 4, right? Negative 3 minus 1 is negative 4. And don't forget to compute for the derivative of your u. So you can write this as h prime of x equals negative 3 times u, which is 5 minus 2x raised to negative 3, times your u, derivative of your u, and your u is 5 minus 2x. Okay, then that means that the derivative of h is, you have negative 3, 5 minus 2x to the negative 3 times the derivative of 5 minus 2x, which is negative 2, right? It's negative 2. And simplifying, we have negative 3 times negative 2 is 6. This one is negative, so we can put that into the denominator, cube. Okay, that's it. For the rest of the problems, we'll do that in the next video.